Alright, so here's the 5-4 assignment. We're going to start off by proving some identities, so you're going to want your formula sheet out. This first one here, I guess you could do it multiple ways. We did certain ways in the notes. But definitely the fact that 4x is here means that we could maybe even bring it into sine of 2x plus 2x, or whatever it is that you would like to do there. But I'm actually going to do it a different way here. So sine of 4x is actually going to be sine of 2, and then within there a 2x. And what that's going to do is allow us to use this formula here, where we end up with sine of 2 and then u. And in this case, our u is actually going to equal 2x as well. And so that means I can rewrite it as 2x there and 2x there. So if we go back here, that double angle identity is going to allow me to rewrite this so that I have 2 sine of u, but instead of u, it's going to be 2x. And then cosine of 2x. And so we end up using that formula of 2 times a variable and then plugging it in. Seems a little shorter than the other way. Alright, so this next one here, we've got cosine of cosine of 6x. And so we're going to actually do pretty much the same thing, only now we're using cosine. And remember, cosine is the one that ends up kind of having 2 options. And so we're just going to have to make sure that we pick the option that looks like this, with 2 cosine squared and then a minus 1 in there. So if we go to our formula sheet, again, cosine of a double angle, we're looking for this one because we've got 2 cosine squared, right? But again, our u is equal to, in this case, 3x this time. So if we go back, we can rewrite this so that it's actually equal to our answer, which is just going to be 2 cosine squared, but then of course that was of the 3x, and then minus 1. Alright, so moving on to the next one, let's see. I'm going to first start out by rewriting cosecant. So instead of 2 cosecant 2x, I'm going to have 2 on top, and then cosecant actually makes that the sine is on bottom. From there we see that we have a double angle, and so I'm going to go ahead and rewrite our sine of 2x using our formula. So we're going to have 2 sine of u cosine of u, or whatever the variable is. From there we can see that the 2's reduce, and so we don't have that piece anymore. But then keeping the end in mind, right, we always want to do that, I'm trying to get a tangent, which is sine over cosine, and I'm trying to get a cosecant, which is 1 over sine and another sine. And so if we take a look at what we have, we have a cosine and a sine, but we need a sine and a sine on top and bottom. And so technically I can multiply a sine over a sine and distribute that within. So if we distribute that in there, we're going to rewrite this so that we have a sine over a cosine, and then a sine with a sine on bottom. And so in that case, this sine over cosine becomes tangent, and this 1 over sine squared can actually be rewritten as cosecant squared, which is what we wanted, and then the tangent of x. Alright. So, moving on to the next one, we have a cotangent of 2x. Alright, so this next one here, we have a cotangent of a double angle, but of course cotangent isn't one of our formulas, so if we change it to tangent, to change a cotangent into a tangent, we need a tangent in the denominator, so I can rewrite this as 2 over tangent of 2x. Which means that if I use my double angle, I still have 2, but I'm going to have to multiply it by the flip of what tangent equals, which is over here. 2 tangent, u is now going to be on the bottom, and 1 minus tangent squared of u is on the top, in order to have it equal cotangent. So again, 1 minus tangent squared of our x in this case, and then that's over 2 tangent squared. Oh, sorry, just 2 tangent. So then taking a look at our 2's, those are going to cancel. And so we'd be left with 1 minus tangent squared over tangent. But of course, if you have a fraction, you can split that up. So we have a common denominator, so 1 over tangent. And then that's multiplied by tangent squared over tangent. But if we cancel one of those tangents, we're going to end up with 1 over tangent, which becomes cotangent. Oh, I have a times, but that's a minus. Cotangent of x, and then minus 1 tangent left on the top. Alright, moving on. Our next one is sine of 3x. And so we're going to go ahead and try one of those addition of our angles. So we can rewrite sine of 3x as sine of 1x plus 2x. And in that case, then we can use our, where is it? Sum and difference identities, where we have sine of these two things added. So rewriting it, we're going to have sine of x times cosine of 2x, and that's going to be added to sine of 2x and then cosine of x. So then we're going to use our double angles to rewrite each of these. So cosine of 2x, taking a look at what we want it to be, there is a cosine squared in it, so I'm probably going to end up using this one here, so 2 cosine squared of our variable minus 1. And then for sine, of course, there's only one option, so 2 sine of the variable, cosine of the variable. And then that's still times cosine over here, and still times sine over here. So this is being a sine multiplied by all of this. And so what I'm going to do is actually take out a sine from each of these two sections and be left with a sine out front. And then inside, we'll have 2 cosine squareds of x minus 1, and to that we'll add 2 cosine squared. Right, because cosine times cosine is cosine squared. So that technically means that, let's see, we have 2 cosine squareds x here, and 2 cosine squareds x here, so we actually have 4 cosine squared of x. And then, of course, the minus 1, and then all out front, a sine. All right. The next one is the almost the exact same problem, but not. And so I'm assuming because of that, it's probably going to change which cosine we pick, so that we can actually get something that has a sine in it instead of a cosine. So as we look through our options here, we're going to probably end up with this one replacing it instead of this one. So let's see, which line are we going to change? So we're going to change from here. So it's going to repeat as we have from before, but then from here, we're going to end up just with sine of x. And then our cosine of 2x is now going to be 1 minus 2 sine squared of x. And then to that we're adding the 2 sine cosine for sine of 2x. And then the other cosine of x. Alright, and actually, because of the way I'm working this, I'm actually going to use the other one, this one, cosine squared minus sine squared. Okay, so just as I did before, I'm going to take out that sine from both of them. So the sine goes out front, and then we're left with cosine squared of x plus sine squared of x plus 2 cosine squareds of x. And then I'm going to use the Pythagorean identities to change both of these into their equality of cosine squared equals 1 minus sine squared. So we're going to have our sine of x, and then the first one is going to equal 1 minus sine squared of x. Then we've got our original sine squared. Oh, is this minus? Yes, oops. Forgot my symbol here is a minus. So right here we're at a minus as well. Which means that right here is minus. Okay. Lost a minus sign, that's not good. Okay, and then we've got plus 2 and then another 1 minus sine squared of x. Alright, so finally got a lot of sine squareds because that's what we need for this piece. So let's see, sine of x is still out front, but then we have 1 minus sine squared of x, and then another sine squared of x being subtracted, and then 2 distributed into here makes 2 minus 2 sine squared x. So that means I have 1 sine squared x, 1 sine squared x, and 2 sine squared x's that are being subtracted, so negative 4 sine squared x. And then the other piece is there's a 1 and a 2, and so that's going to make your 3, which I have left a very large space for. Alright. So that one was a fun one, and again, even though this is a video of me doing this, I did have to pause the video on that one and kind of double check what I was doing, so it's just working it out and seeing what works or not. I did try to do that different piece up here, and then it didn't really get there, so it actually like super canceled, and I got like the number 1, so not really helpful. So you can always just try one piece and then go back and try another, and of course that's frustrating, but it's also kind of how it works. So alright, so the next ones are, let's see, cosine of 4x. And so again, we can use our double angles identity here. And so the way I'm going to start this one is 4x is 2x's. So we're going to do cosine of 2 times 2x, which would be your 4. Alright, from there, we're going to rewrite using, let's see, lots of circles. We're going to rewrite using this guy right here, the 1 minus 2 sine squared of the variable, and in this case the variable is 2x. So 1 minus 2 sine squared of the variable. And our variable is 2x. Alright, then we have to kind of remember this shorthand idea that sine squared of 2x is actually, or can actually be written as sine of 2x, the quantity squared. And so officially I can rewrite this piece, sine of 2x, using its identity over here of 2 sine of u cosine of u, or whatever the variable is. So I'm going to have 1 minus 2, and then inside we're going to have 2 sine of the variable, cosine of the variable. And then of course that quantity is squared. So then I can apply that square to everything inside. So 2 is squared, sine of x is squared, and cosine of x is squared, and so we end up with 1 minus 2 distributed into 4 sine squared of x and cosine squared of x. But of course, since this is all now multiplied, we can take away these parentheses and just end up solving 2 times 4, which makes 8. Alright, and then our last one like this, we've got sine of 4x, and let's see how it's turning out. Okay, so we can start how we did with cosine of 2 times 2x and make this sine of 2, and then our value of 2x within. And so the interesting part about that is that this is actually bringing us back to our first problem that we did, and so we end up with sine of, 2 sine of 2x, and then cosine of 2x. But, and that's actually where that first one wanted you to stop, but now we don't want to stop there. Instead, we want to continue on, so sine of 2x again is another 2 sine, but this time it's just of the variable itself, and then cosine of the variable. 2 still out front, and then cosine of 2x can be rewritten as, especially if we're looking at this piece here, it can be written as 2 cosine squared of the variable minus 1. And of course that has a subtraction in it, so it ends up getting a parentheses. And then to make it look like our result that we want, we just put our 2's together and make 4. And so 4 sine of x cosine of x times our other quantity of 2 cosine squared of x minus 1. ends up with our answer. Or at least what we wanted to prove. Alright, so continuing on, we're now just going to use some half-angle identities in order to find an exact value without a calculator. Again, we are not necessarily solving them or reducing them as much as possible, but just as much as we can. So let's see. The first thing I'm going to do is change all of these into their angle equivalents by multiplying by 180 over pi. And so this first one here ends up being actually sine of 75 degrees. And then just to continue, this one's going to be tangent of 105, and then this one's cosine of 22.5. If we multiply by that, changing from radians to degrees. So we're going to use some half-angle identities, so that means that I need to find out what can be done to 75 in order, what number is divided by 2 in order to get 75. So that means that we're actually going to be doing 150, because 150 divided by 2 is 75. Just as we're on a roll here, double of 105 is 210, and then double of 22.5 is 45. Continuing on, this is going to be sine of 30 over 2. Tangent of double of 195 is 390. And then cosine of 150. And then just so we're on a better page, we're actually, let's see, 390 is actually 30. If you kind of loop it around the circle there. So all we need to do here is identify our formulas that we're going to use. So that's these guys down here. So we've got some sines, so we're going to do plus or minus 1 minus cosine of u over 2. Cosine of u over 2. And remember that u equals that new numerator number, so 150 for this one. Whoops. 210, 45, 30, 30 again, and 150. Then we do want to actually evaluate what cosine of 150 is. So let's see. Cosine is x, and it's of 150, so negative square root of 3 over 2. So our value here is going to be the plus or minus square root of 1 minus, 1 plus square root of 3 over 2 over 2. And again, you can get very fancy on simplifying that if you would like, but that is perfectly acceptable that you knew how to plug it in and then at least evaluated the cosine, sine, or tangent. Alright, so then the next one, we've got a u of 210, and we're in tangent. So since I don't really like these square roots, I'm going to try sine of u and 1 over cosine of u. So we need see if I remembered that. Yep. And so now we need to actually evaluate what is sine of 210. So sine of 210 degrees is the y value at 210, so negative a half. And then that's going to be divided by 1 plus, or actually minus, the square root of 3 over 2, which was cosine of 210. And again, that could be nicer, but that's just how I'm going to leave it. I'll make one of them nice. Alright, so then we have cosine, the next one. And cosine, according to our formulas, is going to be 1 plus cosine of u over 2. So we're going to have plus or minus 1 plus instead of minus cosine of 45 over 2. And so technically cosine of 45, let me see, is square root of 2 over 2. And then that's going to be over 2. Alright, the next one is sine, and so we're going to do the same formula as above here, and so we'll have plus or minus 1 minus the cosine of 30 over 2. But that can be reduced, and so we actually have, or simplified a little bit, cosine of 30, which is the x value at 30, so square root of 3 over 2. Over 2. Alright, and let's see. Then the next one is tangent, and so tangent, we're getting 30 as our u value, so going back to this one up here, got sine of 30 over 1 plus cosine of 30, and so that simplifies. Our sine of 30 is a half. So a half over 1 plus cosine of 30. Oh. And cosine of 30 is square root of 3 over 2. And then our last one here, we have cosine of 150. So the cosine was this one. So plus or minus 1 plus cosine of 150 over 2. And so we're going to end up with cosine of 150, which is the square root of 3 over 2, and then over 2. And again, if you're comparing it with the answer key, you just need to find your decimal and match that. So, next ones we're doing without a calculator. So we've got f of x is sine x and g of x is cosine of x. And we're going to find f of 2x. So f of 2x is going to replace the x in our function of f with 2x. And so that means that I'm going to have sine and instead of x of 2x. And sine of 2x from our formulas equals 2 sine x cosine x. And so when we look at what they gave us, sine of x is technically f of x. And cosine of x is technically g of x. And so we're looking at 2 times f of x g of x, which is this one. Alright, and then our last one, they want you to find sine of 22.5. And honestly, it does say without a calculator, so if I was using a calculator, I would just type that into the calculator using degree mode, and then compare my decimals. But let's see. We're going to end up doing sine of 45 over 2 using our half angle. Plug that in and we get plus or minus 1 minus cosine of 45 over 2. Plug in our cosine of 45 and we get 1 minus the square root of 2 over 2 over 2. And then changing our 1 to a 2 over 2 and changing our divisor of 2 over 1 means that each of these is multiplied by a half. And so we actually get plus or minus the square root of 2 over 4, so 1/2 minus square root of 2 over 4. And so if I keep that actually as 2 over 4, we end up simplifying to this one actually and not this one, because of the